All right.
So I guess we can start off just if you had any questions for the last test. I don't know if you do or not, but did anyone have any questions?
Yeah, on number 6B.
Actually, is it okay if I go and do my test real quick?
Yeah, I had a question.
Yeah.
And then it said find all points where tangent is parallel to the line y equals negative x.
Yeah, that's my question too.
I got that whole question wrong, or minus 2 points, so I don't know.
Which one?
For 6B.
6B. Probably got that wrong. Oh no. Got that right. Wait, I'm looking at the wrong thing.
Find points.
Yeah, I was looking at the wrong thing. Did you say 6B? No, I got that wrong. I just got the Y's mixed up. Like I had it right until a certain point.
Like I don't really understand. Like the first step you do, you find the derivative.
Mm-hmm.
I don't know. The derivative is equal to
-1.
Yeah, it's equal to -1, the slope.
Wait, how did you do that? You just plug in.
It says the tangent line is parallel to the line y is equal to -x, and the slope of the line y is equal to -x is just -1. And both parallel have the same slope.
Mm-hmm.
Since the derivative is just the tangent line, that means that slope's also like the slope of the tangent line, so it's just -1.
So you set y prime equal to -1.
Yeah, y prime is equal to the slope, which is -1.
Yeah, and then after you solve, you should get y is equal to x, and then you plug that back into the original equation, and then you should get the points.
Oh, you plug that into x squared plus xy is equal to 1 minus y squared?
Yeah.
And then you get 2 squared minus. And then did you get plus or minus root of 1/3?
Yeah, that should be it.
That's for the x?
Mm-hmm.
Yeah, after you plug it back into the original equation and you solve it. I think it's. And then, is that your answer? Oh, and then you plug that in again, right?
Yeah, to find the y value.
Wait, so you get -x. I'm so confused. So you say -1 equals -2x minus y over x plus 2y?
Yeah.
And then you get -x minus 2y equals -2x minus y. And then whenever there's a y, you just put in -x.
Oh no, you can keep simplifying after that. And you can simplify that all the way to y is equal to x.
And then when you get that, you put x into the original equation where y is.
Yeah, and the x squared plus xy is equal to 1 minus y squared.
Yeah.
Just wondering, so let's say you get like, so on number the question again, or do I just like
I couldn't hear you, it like lagged. Douglas?
think his thing broke.
All right. Well, back to 6B. Like, I'll just wait for Douglas to come back. After you get x, wait, did you get to x is equal to plus or minus square root of 1/3?
Yeah, I just got that. I think that you plug 1/3 back into the original equation.
Yeah, and then that's how you find the y
Oh
coordinates. I
no,
think.
no! All you have to do is plug it into y equals -x, because that's what the parallel. I think that's all you have to do, or maybe not.
I have no clue.
Actually, I don't think that's right.
I don't know. I would think you would use the original equation, but honestly, I'm not sure.
I just don't know what the y is. I don't know.
So yeah, and is there any other questions?
That was like all I had.
The rest of mine were just like.
The rest of them were like really stupid mistakes.
Yeah, like chain rule.
Yeah.
Thing.
Did you get 7A wrong?
I got 7B wrong.
I got 7B wrong because I accidentally plugged in the wrong number.
Yeah.
Really?
Yeah.
I just forgot to put like when you change the exponent from 5 to 4. I forgot to put 4, so I just got each one off. I didn't get it full. I got like half credit. Yeah, and then all the other ones were just change and derivative stuff.
Mhm.
Did anyone understand the extra credit part?
No.
She wrote it on.
Oh yeah, she wrote it on the back of mine.
Yeah.
F of x equal to.
So Safari kicks me out sometimes. I don't know.
Oh, yeah, wait, what were you saying? Weren't you asking something?
Yeah. So on question number 2, I basically got it right, but I didn't put like enough digits after the decimal place. So basically, she said it has to be like 8. Do I have to rewrite like all that I did, or do I just rewrite the?
Yeah, you have to rewrite all of it. For number 2, is that what you're talking about?
Yeah.
So I got most of it right. It's just I didn't get all the points that's slowing down.
Yeah, I forgot you see like the very end of the curve or whatever. I didn't put. There's like
really short interval.
I got like 6.842 as the last one.
Yeah, someone I didn't put.
Oh, I didn't get that.
And then didn't use 3 decimals either.
I got from 6.84 to 7, but
That's like, wait, Douglas, you like went out. What on 6B? After you get the x, what do? Do you plug it in the original equation?
yeah.
You plug into x squared plus xy.
You should, because I mean that's just that'll give you the coordinate.
Yeah. All right. Any other questions on the test?
Mm-mm.
All right. Do you want to go and talk about 4.1?
Yeah, 4.1 is hard.
Yeah, it was really.
Yeah, it was really confusing at first.
I didn't get one problem right. Like I have to do this packet. I feel like I'll get it after I do this, but like I just had no idea what to do. Every time I got it wrong.
And there's so many things where I feel like I'm not like it makes sense once I look at like what she does, but it's like I can't remember that when I'm like by myself.
Yeah.
Remember what?
Just like the steps I'm supposed to use, like for example, there's like a bunch of problems like in the homework. I remember when you needed to like notice that like when you're taking the derivative of something, like it's not moving in the problem, so you make it go to 0 or something like that. And then there's another time where you had to get from 2 variables to 1 variable by like, making them both each or something like that. Yeah, just a bunch of stuff, and then knowing when to make it positive or negative, based on where it's moving.
For me, like the triangle one is the easiest. Like if
Yeah.
one person's moving north and one person's moving south, those ones are like I still like get them wrong, but they're the easiest ones, and I always get the I don't even know the volume ones, or if it's
Yeah, I wonder if she's gonna give us the equations for the volume for that.
Was it just me, or did the homework for anyone else take a long time?
Homework took me a while.
Yeah.
It took me like the whole like long block and like my study hall, and then like a little longer too. But that's because I had to like check, like I'm like really slow at this word problem stuff.
Mm-hmm.
Yeah, the 4.1 textbook work took me a while.
Yeah. And then I still have to do that other extra practice sheet. Did anyone still have to do the practice sheet yet?
I haven't done
No,
it
I
yet.
haven't started anything yet.
The extra practice work.
Yeah.
It's due tomorrow, but we also have a video due tomorrow. So
Yeah, I watched the video for 4.2, but
is it
That was done.
easier?
it's really just talking about like maximum minimums. It's
I
not
started
really
the video.
Okay.
Mm.
um
I mean, if you guys want, we can do like some of these extra practice.
oh yeah.
Because I don't know what else we go over. I feel like.
Yeah, so do you want to do 2, like problem 2 for that?
Okay, thank you.
Sorry with
Wait, which one do you guys want to do? Number 2?
On which worksheet? Which one?
there's a worksheet due tomorrow. It's called the extra practice sheet for 4.1, and it should be on her haiku page. Yeah, it's another 4.1 thing where you turn in the homework.
Do we only do page 4?
Yeah, page 4,
right.
problems 2, 5, 9, and 10. 2, 3, 5, 9, and 10.
2, 3, 5, 9, 10. All right.
Oh, those are the only ones we have to turn in.
Yeah.
Oh, I thought we had to do all 12.
That would take
Okay.
forever.
Use some of them for the like quiz review and test review.
What was that?
I think I'll save a few of them for like quiz review and test review.
Mm-hmm.
Yeah.
Alright, does everyone have it?
Mm-hmm.
Yeah.
Alright,
Yeah.
we'll start on number 2.
Wait, and then she wrote something in the Slack because Haley and Sophie were having trouble.
Yeah.
You know,
With number
something
two?
like that.
Yeah. With the units. So what
It's
it switches between feet and inches. Because it says the base is 3 feet, but when it gives the rate, it's inches.
oh,
So the base would just be 36 inches, and then since the height is
and it's 4/3.
yeah 38 inches.
I don't know what the unit is though. Oh, 4/3 the radius. Oh, that's like the Like I don't even know what formula. It's that the volume is 4/3 pi r squared h or something.
Yeah, something.
Mhm. Oh, it's just pi r to the third. No, it's. Oh yeah, it's pi r third.
Wait,
Oh wait, what?
how much is the volume?
Like
Like-
here it says that the volume we're supposed to use 1/3, not 4/3.
Wait, what's the volume formula?
Volume is 1/3 pi r squared h.
So
And
for
the
that,
height is equals to 4/3 the radius of the base. Like
so all the information we have is height is equal to 4/3 r, I guess.
yeah. And then the base, the radius is 36 inches.
Oh, you're supposed to make it inches.
Yeah. because and then it's increasing, so that means like a dB dH dt is 3.
Oh, the derivative of the radius. Or
The base, radius.
wait, wouldn't it be the radius of the base? So wouldn't it just be the radius still, right?
Yeah, I think.
So it's the radius increasing at 3 inches per minute.
And then the height is 36 is 4/3 of 36, which is 48, I think. But then I don't know what the
Yeah, 48. And then
I don't know what the volume is or what the derivative of the volume is or derivative of height. I don't even know what we're trying to figure out.
oh, we're trying to figure out the derivative of the volume.
So we need dV dt. But do we have the?
Oh yeah, and you can find the volume by just plugging in
But is the
to 1/3.
derivative of the height the same as the derivative of the base, or is it 4/3 of that?
Hey, I'm sorry, what?
Okay, so we have like the radius, the derivative of the radius, the height. But do we have the derivative of the height, or is it just 4/3 the derivative of the radius? Like I don't get what we do for that.
Oh.
You know?
Oh no! In the question it says his height is always equal to. Oh wait, that's 4/3 the radius of base. Oh yeah, I don't know.
And then we would have to say the volume dV dt is 1/3 2.
Oh wait, no. We would change h to an r before we find the derivative, right? We would only have one. It's like one of those problems where you make the variable the same. Make the variables the same.
Oh, yeah, because you can convert the R, like you can count.
Yeah, h to r.
Well, h we know is 4/3 r, so maybe we just keep it as that.
Yeah, that's what I would guess.
4/3 r. So then, so it'd be. Oh yeah, so now the we don't need the derivative of the height, so.
So then it's
1/3 pi r squared. So would it be?
so pretty much you get the volume is equal to 1/3 pi times 4/3 r cubed, right?
But then you have to move the 3 down, so it'd be 4. Like, because wouldn't it be volume's equal to 1/3 pi 4/3 r cubed, and then you have to make the 4/3 r cubed 12/3 r squared for the derivative.
Wait, well, finding the volume, wouldn't you want to find it in inches since it gives you the derivative in inches? Like the rate in inches?
Or isn't it already in? Didn't we convert it to inches already?
Yeah.
So then wouldn't the volume just be 1/3 times 48 inches times 36 inches?
I think it's like 4/3.
Well, no, because the radius is always changing. So I don't think you can plug it in yet. I thought you need to find the derivative first.
But it says the radius of the base is 3 feet.
The radius
So-
of the base. Oh wait.
Are we supposed to put everything in feet, or are we supposed to put everything? I don't think it matters.
But I don't know. Do we plug? The question is, do we plug it in before or after we take the derivative? I'm not sure.
After, I think after.
Yeah, plug it in.
Yeah, You want to just because if we plugged it in now, like the problem would already be solved. It wouldn't really make sense.
I'm gonna look at one of these examples.
All right, so I'm just gonna find the derivative of 1/3 pi times 4/3r cubed.
Oh my gosh, I put in the wrong formula for the.
All right, yeah. Did everyone get to that step so far?
Next step.
To just getting what the volume is equal to, like before we take the derivative.
Oh, I took the derivative at first, and then I plugged it in.
Oh yeah. That's what I'm about to do. Find the derivative. Yeah.
Yeah, I got this wrong.
And so you get like 4/3. The derivative of v is equal to 4/3 pi r squared times dr/dt.
Yeah. Wait. What's after r squared?
Or the derivative of r, so dr/dt.
Yeah. I got that.
Which is 3. But
And then now you can plug in whatever you have.
that's like what I did, but I got 400. Wait, like a number way bigger. The answer is 3 pi.
Oh wait, did you post the answers? Where's
Yeah, it's on the next sheet.
Yeah, it's still in the packet.
oh. Wait, let me pull it up. Wait, did you plug in 36?
Yeah, but then when I divided it by 12, I got like, to put it back in feet, I got 4/3 times 36 squared times 3. And then divided by 12, I got 432.
Yeah. Yeah, it's some like crazy number.
Mm-hmm.
What number?
Wait, if you could second. Oh, maybe. Wait, how'd you get seconds?
Because it's the rate of change.
So what did you get after plugging in the r, the rate of change of r?
I ended up getting like 16,286.
What?
Yeah,
How?
I didn't multiply it by pi. I left that out. And then I got 432.
Wait, I thought, isn't it just 36 squared times, wait, maybe you don't do 36.
Well, if you're doing it in inches, like, unless you want to keep it in feet.
Yeah, I'm confused. I don't know.
Well, we can come
Maybe
back.
it's supposed to be, because we did 4/3 r times r squared. Maybe it's 4/3 r and then the whole thing is squared.
Well, if you look, the answer in the end is in feet. So
The what?
the answer in the end is in feet.
Then we
So
just divide everything by 12.
We can just keep it in feet to begin with.
But I still didn't get it.
Keep it in feet. maybe do we change? You see how the derivative of r is equal to 3 inches per minute?
Yeah.
Maybe
Mhm.
do we convert that to feet per minute?
Okay. So it'd be is equal to 1/12.
1/4.
1/4. Yeah, I don't know why I said 1/4.
Yeah, 3/12, 1/4.
So the radius is 3, and the derivative of the radius is 1/4.
What would that get?
So the derivative of the what is equal to 1/4?
The radius.
No,
Yeah, I
that's
got
good.
3.
You got 3?
Yeah. 4/3. And then I don't do the pi. I just did 4/3 times 3 squared times 1/4 is 3. So it's 3 pi.
Yeah, that's like 9.4 something.
And the answer is 3 pi.
Oh, it is?
Yeah. So yeah, I don't get why when we did it in
Oh.
inches it didn't work.
Okay, I was looking at the wrong answer problem.
Which I think is like really weird.
One third squared.
Yeah, I got 3 pi, right? Is that 3 pi? 3 pi?
Mm-hmm.
Oh, so we ended up plugging in 3, not 36.
Yeah, but I don't get how you know.
What did you get for the volume?
Oh, are we supposed to find the volume?
No. We want to find dv dt.
You don't even need to know the volume.
No. Because it's only how fast it's changing. Not what is the volume, I guess. Oh, yeah, because if it was what is the volume, we wouldn't have to find the derivative of anything, I don't think. I think, yeah, we would just plug in r.
So you say dv over dt is equal to derivative of r over dt times the radius, which is 3 feet times the times
So what also I find kind of hard is knowing the units.
Mhm.
That always confuses me.
Yeah, so I guess my question for this one is why when we did it in inches and then put it back into feet, it didn't work.
Yeah. Well, we end up converting everything though to feet. Oh wait, you're saying if we put everything into inches, why wouldn't that work?
Mm-hmm. Wait,
What did we do with the height?
now I'm confused because I feel like we got the right answer and we did it wrong.
Wait, yeah, hold up.
Okay,
Limit
so for
9
the height,
Wait, what?
we replaced the height with 4/3 r. So then we had volume equals 1/3 pi 4/3 times r cubed.
Mm-hmm.
And then we got, when we took the derivative, we got 1/3 pi times 12 over 3 r squared, which is 4. So it's 4/3 pi r squared. And then we just plugged in 3 for the radius and 1/4 for the derivative.
Oh wait, no. After you forgot though, after you do 4/3 pi r squared times the derivative.
Oh,
did you already say that?
No, I forgot that.
Yeah.
Okay.
Derivative of r.
If you know that the height is 4/3 times the radius, then why can't you just do 4 for the height?
4 for the height?
Because we can't do 4 for the height because we don't have the the derivative of the height. So we have to put it all in terms of radius. I think if we had the derivative of the height, then we'd be able to put the 4 in.
Yeah, I'm kind of. But yeah, I think we did it right. I think we got it.
Same.
Pretty confusing, but we got there.
See, like once I saw that we had to put it in feet, then we all got it. But like I don't know what I would have done.
Yeah, I kind of have to have the answer there, like to check my stuff.
Okay, should we try like one more and like not look at the answer and then just see if we get it, and then that can be like the last problem.
Let's try number 3.
Hey, I gotta go. Sorry, guys.
No, you're fine.
All right.
All
So,
right. See ya.
Number 3.
yeah. Right.
Okay, so volume, this is equal to. So we know the volume is equal to 50.
Wait, this one I'm actually so confused.
What?
We don't know.
Because right now
Which-
the area is equal to 50, the derivative of the length is 2, and the length equals 5, but we have to find the rate of the perimeter.
The length. Increasing side.
Hmm.
It's fun stuff.
Oh, so from this, I think we have to find.
What other two sides are?
Right. Well, the area is equal to base times height, right?
Yeah.
So, what information? Like, I'm just putting. I guess I'll just put, like I had it in x is for the sides that are increasing. That's just what I had.
Okay,
And
I'll
then,
do.
I guess for the sides that are decreasing, I'm just gonna put h.
Okay,
Is that how
so
we should all do it to make it more easier for like everyone to do it the same way, or does someone else do it differently?
I just did X and Y.
And just having y being the height or the other side.
I have Y being the height and no wait. I have X increasing and Y decreasing.
Yeah.
Oh, hard.
So the information I got out of this is that the area, which is equal to b, base times base would be x.
That's what I'll do.
So pretty much is xy.
Mm-hmm. Oh, I think that it says the length of an increasing side is 5. So if we just plug in 50 equals X times Y, then we can do 50 equals, we know that the increasing side is 5, so it's 5 times Y. So I think Y might be 10.
Y has to be 10.
So it's find the derivative y at when y is 10.
Yeah.
Wait, find the
I don't know how to
derivative.
do that though.
I'm confused. How do you guys get that?
Okay, so the area is 50
Mm-hmm.
and that x equals 5 because it says that the length of an increasing side is 5 inches.
Uh,
But we need to
So I
find
did
is
50
the,
equals 5y and then y is 10.
what we want to find is the derivative of the perimeter.
So perimeter is 2x plus 2y.
Mm-hmm.
Derivative.
wait, derivative is
Derivative of
2x.
y though.
But you said the derivative is 2x plus 2y.
No, we're finding the derivative of 2x plus 2y. That's the perimeter. We're
Wait,
looking for the
No,
derivative.
but first we need the derivative of y to be able to find the derivative of the perimeter, I think.
wait, just wondering if x is 5 at this point and we can solve, and we know if x is 5 and we know that the
So hard.
if x is 5 and we know that the area is 50, doesn't that means that y is equal to 10?
Yeah.
And if perimeter is just equal to 2x plus 2y,
Yeah.
you just plug them both in and then you find that the perimeter is equal to,
That actually makes sense.
Yeah, perimeter is 30, right?
yeah, equal to 30.
But like, how to find the derivative?
But if that's what it is, like, then wouldn't that mean it's just a constant?
No, because we have to find. I think
The rate of change of the perimeter.
We're able to change it. Only the area is the same. Yeah, only the area is the same. Perimeter is changing too.
Let me see.
Oh, I think that we have to do to find the derivative of y, we have to do the chain rule because it's like x times y. So it'd be like x.
Yeah. Wait, how long should the Google Hangout be? The Sunday one?
We're already past.
Yeah, we can pretty much end it already, but
Yeah,
we
I'm
just
thinking
finish.
like, how about we end it now and we can talk about it tomorrow? We can ask this question Slack. It's already a little late. What do you think?
Do you just want to finish the problem, or
Yeah, I can just finish the problem.
Okay, yeah, never mind. Okay. I just want to.
yes? Or we'll do it quick. We'll do it quick.
Yeah.
Oh yeah. So, do you guys know what the next step is after you find the perimeter?
No, I don't feel like we have to find the derivative of y, but like I really don't know.
But yeah, because we don't know the derivative of y. That was like one of the things that we don't know. All right. Right. Sure. Well, if we don't have any idea, I guess we can.
Wait, I think I may have. Hold on 1 second. D. Two.
I just don't know how to, like, what equation to use to relate all of these things that we need.
Oh, yeah, I have no idea.
Yeah.
I just got 30, and like that's not the answer is -4. All right. I say we put this in the Slack because none of us know what to do.
Yeah, Tony, you can end it.
All right. See you guys.
End
Bye.
it.